Arithmetic progression. So what is arithmetic progression? Arithmetic progression is a sequence that has a common difference between each term. For example, for the sequence 1, 4, 7, and 10, the difference for each term is plus 3, and the first term for the sequence is equals to 1. Next is the formula used in the arithmetic progression. The first formula is Tn equals to a plus n minus 1d, which can be used to find the n term, while the second formula, which is Sn equals to n over 2 in a bracket a plus 1 close the bracket. Or you can also use Sn equals to n over 2 in a big bracket 2a plus in a bracket n minus 1 times d to find the sum of the n term.
So now we're gonna continue with application of arithmetic progression in daily life. The first one is taxi fares. So if a taxi charges RM1.50 per 1 kilometer ride, and the taxi fare per 1 kilometer arithmetic sequence can be described as follows, which is RM1.50 for 1 kilometer, RM2 for 2 kilometer, and so on. So, what is the taxi fare that Wazir needs to pay if the distance of the ride is 60 km? So the first step is we have to analyze what is our first term and our term that we want to find and the common difference. So the first term is 1.5 and the term we want to find is 60 and the common difference is RM1.50. So we can use the term formula, which is a plus n minus 1d, and we just substitute our term into the formulas. And then we got 90 for the 60th term. So the taxi fare that Wazir needs to pay is RM90.
Alright, next we continue with geometric progression. So if the word of geometric progression, you must remember the word of common ratio. Okay, what is common ratio? The first example we can see that is 3, 6, 12 and 24. So the common ratio is 2. I can get 2 by 6 divided by 3 or 24 divided by 12. And the second is negative 6 divided by 2, I will get negative 3. And the third example is that I can also 9 divided by 3 or 81 divided by 27, I will get 3. So this 3 arrangement is geometric progression. Alright, in geometric progression there is 3 formula that you can use. That is first, n term of geometric progression, that is a r power of n minus 1, and second one is sum of geometric progression, a 1 minus r power of n divided by 1 minus r, and the last formula is sum of infinity, that is a divided by 1 minus r. This formula can only use when r is negative 1 until 1 only.
Okay, as we move on, I want to discuss about applications in geometric progressions. So we have a situation here. In the year 2010, the economy in Malaysia has been improved. So the government decided to increase their YTP scholar students' monthly allowances up to 5% annually. The monthly allowances in 2010 was RM100. If Awish is going to be selected as a YTP scholar student in 11 years' time, calculate the amount of monthly allowances he will be getting in his second year as a YTP scholar. So the first term is RM100. The number of years is 11 years plus 1 year. Why do we need to plus 1 year? It's because since 2010 until the year that Awish received a YTP scholar is 11 years. But we need the amount of monthly allowances that he will be getting in his second year as a YTP scholar. So we need to plus 1 year. So we have the common ratio. Is it 5%? It's wrong. It's not 5% because if we use 5%, it will be decreasing. So we have to use 105%. That would be correct. After that, we have the formula of the term in geometric progressions. We just need to plug in everything. We will get RM171.03.